Hey guys, so I'm going to make a video on this lesson since I didn't want to do it in class with the earpiece because the audio is not that great. So we went over 7.2, which is angles and lines, and there's kind of one big idea, two big ideas that kind of carry us through this whole little section, and that's this idea of vertical angles. So up there we have the definition. Vertical angles are two non-adjacent angles formed by two intersecting lines. And that's just fancy talk for essentially angles that are across from each other after two lines intersect. Remember, adjacent is a fancy word for next to, so non-adjacent means not next to. So, for example, 4 and 3 are going to be vertical angles. So angle 3 and angle 4, and then angle 2 and 1. So angle 1 and 2 are also vertical angles, right? And this makes sense because those are the ones across from each other. They're non-adjacent, right? Like, for example, if we're looking at angle 1 here, the angles right next to angle 1 are 4 and 3, so not those ones, but the one across. So a non-example here is angle AEB. So if we go AEB, that's this one, and DEC is this one. Those are not the same, right? Or those are not vertical angles because this is a different line, right? It's two intersecting lines, but we kind of have like three things going on, right? Just because it looks like they might be kind of close doesn't mean they are. They need to be two individual lines, and that's it. Right. So, um, some more terminology. A transversal is a line that intersects two or more lines at different points. So, for an example, we have this is the transversal intersecting these two lines. Right. And then some more terminology. Exterior is going to be anything on the outside of the two lines. Right? And the interior is going to be anything on the inside of the two lines, just like a house or a car. That's the same definitions for interior and exterior. Interior inside, exterior outside. And then we have a couple other things: alternate interior angles and alternate exterior angles. Alternate interior ones, well, those are going to be the angles on the interior, so 3, 4, 5, and 6. And alternate kind of means like switch. So the alternate angle to 3 is 6. Those are alternate interior angles. The alternate interior angle to 4 is the other one that's on the inside and across from the line, the alternate side. Now the alternate exterior angles, right? If I'm looking at 1, the other or the exterior angles are 1, 2, 7, and 8. So now if I go over, alternate kind of means like switch sides. So 1 and 8. And then the last one, if I'm looking at 2, the alternate exterior angle to 2 is 7. And we'll have to get comfortable with that terminology for later. So this is the theorem, one of the theorems that carries us through basically the entire section. Vertical angles are congruent. So that means if I have vertical angles, they're congruent. So that angle is congruent or the same as that angle. And then that also means that this angle here is the same as this angle. And where we come up with that is you can imagine it with real numbers, right? We know that a whole line is 180 degrees, right? That's 180 degrees. And so, for example, if this was 30 degrees, that means that this side has to be 150 degrees, right? To make 180 degrees for a straight line, that means that has to be 150 degrees. Well, here we have another straight line. So if this is 150 degrees, that means this is going to have to be 30 degrees, right? And if that's 30 degrees, here's another straight line. That means this has to be 150 degrees. And so that's going to work out with any two lines you intersect. That's why vertical angles are always congruent, because we can generalize that to if this is x degrees, well then this has to be 180 minus x degrees, right? Because added together, 180 minus x plus x added together, they have to equal 180, right? And so that means this one's going to be x, and this one again is going to be 180 minus x. So that's general. It'll work for any angles. All right, that's why it's true. So again, vertical angles are congruent. So that one that one, and that one, and that one. All right. So for an example, if angle MSN equals 89 degrees, so let me find MSN is angle 6 here, right? Because I go MSN is 89 degrees. What is PSL? PSL is angle 4 here. Oh, and look at that. We just said vertical angles, which these two are. Vertical angles are congruent. So PSL is the measure of PSL. Angle PSL is just 89 degrees, right? If this is 89 degrees vertical angle, this is also 89 degrees. Here, if DGA equals 130 degrees, so where is DGA? So that's angle 3 here is 130 degrees. What is the measure of CGB? CGB is this angle. Oh, and it's a vertical angle, so that's 130 degrees as well. Right? Vertical angles are congruent. It's that easy, right? All right, a linear pair is two adjacent, again, adjacent is a fancy word for next to, two adjacent angles that form together to make a straight line. So basically, if you see a linear pair of two angles, that just means that together they make a straight line. So angle 1 and 2 together make 180 degrees or a straight line. And then some recall, complementary angles are two angles that add together to make 90 degrees, and supplementary angles are two angles that add together to make 180 degrees. And so the angles in a linear pair are supplementary because they make a straight line, which is 180 degrees. And again, how I remember which one's which is when I'm writing 90 degrees, at the top of 90, there's like a C, right? You kind of make a C for complementary, right? And then when you're writing supplementary, when you write an S, well, an S is kind of like an unfinished 8, right, for 180 degrees. Or you can think when you're writing 180, you're kind of making an S there for supplementary. So I think that is the good way to think about it. So if measure of MSN is 106 degrees, so that's here, that's 106 degrees. Then what is MSP? MSP is this one here, right? And maybe I'll mark it differently. Well, I know that this whole line has to be 180 degrees. So to find this angle, I need to do 180 degrees minus 106 degrees, right? Which is going to give me 74 degrees. And so if you want to do the subtraction to be for sure, you can. Or sometimes I just like to think about it. Okay, what do I have to add to 106 to make 180 degrees? 74. Angle 4, if WYT is 72 degrees, so angle WYT, that's going to be angle 4 here, is 72 degrees. What is angle UYW? UYW. So this angle here. Well, again, if this is 72 degrees, how do I make 180 degrees? I'm going to need 108. All right, and then the way to do that is if you do 180 degrees minus 72 degrees, you should get 108 degrees. Because the whole line has to be 180. All right, parallel lines are lines that do not or would not intersect if they went on forever. So I'm going to assume that these two lines right here are parallel. And then we have this other theorem that kind of carries us through this section, that if two parallel lines are cut by a transversal, again, transversal would be this line right here, the line that cuts two other lines, then each pair of corresponding angles is congruent. So corresponding angles means ones that basically match up. So if I'm looking at angle 1 here, the corresponding angle over here would be angle 3, right? And then if I'm looking here at angle 2, the corresponding angle here is 4, and so on. 5 with 7, and 6 with 8. Now, if we have two parallel lines cut by a transversal, it's kind of nice because we can, if we have one of these angles, we can find the rest with the theorems that we have. So let's assume that we're given angle 1 here. Well, we know that angle 1 is the same as angle 3 because of right here, corresponding angles, right? Corresponding angles of parallel lines cut by a transversal are congruent. Right. Well, then we also know, due to vertical angles being congruent, that that's also the same as angle 6 and angle 8. And then it kind of goes the other way, right? If we know this angle, we know that this line has to add to 180 degrees, so we can find this angle here. And then it's the same thing around, right? Corresponding angles tells us that's the same as that one. And then vertical angles tell us that these are the same. And so this kind of gets to the next part, that alternate interior angles and alternate exterior angles, when we have parallel lines, are congruent, right? So, for example, I said that angle 1 here is congruent to angle, or let's do interior first. Let's look at angle 2. Angle 2 here, alternate interior, right? The interior is the inside squished between the two lines, and the exterior is the outside. So the interior is squished between the two lines. Alternate means the other side. That one's congruent, right? And then the other alternate interior angles would be there and there, right? And that all stems from going around, right? If I use corresponding angles, this angle is the same as this angle, and then vertical angles. And then it works for the exterior ones too, alternate exterior. So this angle here, angle 1, the alternate exterior angle is going to be on the exterior, the outside, and the other side of the line. All right, and then last one, angle 5 here, the alternate exterior angle to 5 is also going to be congruent, which is this one here. And that really came from that whole idea of, okay, if I know this one, corresponding angles are congruent, right? And then so are vertical angles. And if I know this one, corresponding angles are congruent, and so are the vertical angles. All right. So given that m is parallel to n, find the value of x. Well, we just said that corresponding angles are congruent when we have parallel lines cut by a transversal. So this one is as easy as 32 degrees, right? We know that those two lines, or those two angles, are the same because they're corresponding angles. Given m is parallel to n, find the value of x. This one is also as simple as 54 degrees because those are alternate interior angles. Right? We're on the interior, we're on the inside, and alternate interior means you go to the other side. And they're the same, right? And that really comes from, okay, this is corresponding, and then vertical angle. So if you have to think like that, that is totally fine. If you want to say, okay, well, I know 54 degrees is here, so I know that this corresponding angle here is the same, and then this vertical angle here is the same. But you do need to know later on this terminology, and maybe I should go back here, that these are corresponding angles. For 7, here, we know that the corresponding angle here, if we're given 26 degrees here, we know that the corresponding angle here is also 26 degrees, right? And we know this whole line has to be 180. So if we do 180 degrees minus 26 degrees, we should find what we need. 180 minus 20 is 160. and minus 6 is going to be 154. So this angle here, x, is going to be 154 degrees. Right? Or you could just think, what do I need to add to 26 to get 180? 154. Just because there's 3 lines, there's no need to freak out. All the same rules still apply. Given L is parallel to M is parallel to N, find the value of x. Well, again, we know 54. The corresponding angle up here is here, so that's 54 degrees. And then we know that this whole line has to be 180 degrees. So x has to be what we need to add to 54 to get 180, and that's going to be 126 degrees, right? And the way to get that for sure is you could do 180 minus 54. 180 minus 50 is 130. Minus 4 is 126. Right. And then if it asks for 2 angles, there's nothing really different. And you just have to use all of our knowledge given M is parallel to N, find the value of X and Y. Well, I know that X, alternate interior angles, is 35 degrees. And that's from alternate interior angles. Well, and then I also know that Y is 35 degrees from vertical angles. Right? And you could say from corresponding angles once you have x, but I'm just saying, I'm thinking right here, there's 35 degrees here. Oh, y is 35 degrees because it's a vertical angle, right? They are just the same. And that is going to wrap up 7.2.